Hello everyone, so in this video we are going to solve a question of LeetCode that is sort the matrix diagonally. So let's start with the problem statement. Given an m into n matrix met of integers, sort each matrix diagonal in ascending order and return the resulting matrix, right? So basically we have given an integer matrix and we need to sort this matrix diagonally, right? So let's quickly see the first example. So let me just copy it from here and paste it here. Right, so this is the matrix given to us, and if we write the indexes for this, so this is 0, this is 1, this is 2, this is 3. Similarly, this is 0, this is 1, and this is 2, right? And this is the j component, or we can say j as a column, and this is the indexes of row. We can consider this as I, right? Now let's see for each diagonal and let's find out some combination here, right? So if we find out the combination for the diagonal, so let's start with the first diagonal. This is the one diagonal, right? So the coordinates for this diagonal, right? The coordinate is 0 comma 3, right? This is 0 comma 3, right? And if we just try to subtract I minus j, let me just write I minus j here, right? So if we just subtract I minus j for this, so this will give us minus 3, right? Similarly, let's see for other diagonal. Let's say we have this diagonal 1 and 2, right? So for this diagonal, if we check, so we will be getting, let me just move it here. Yeah, so for this diagonal, second diagonal, this is 1. So for this one we get coordinates that is 0 comma 2, right? And for this 2 we get coordinates as 1 comma 3, right? So if we just subtract this, so for this 0 comma 2 we will get minus 2, and for 1 minus 3 also we will get minus 2, right? This minus 2 and minus 2 are same for this diagonal. So this is basically we are getting this minus 2 for this diagonal. For this first diagonal we were getting minus 3, right? Now let's see for third diagonal. This is the third diagonal, right? For this third diagonal, if we find out the same pattern here, that is I minus j, so this will give us 0 minus 1 is equal to minus 1, right? Then 1 minus 2 is also equal to minus 1, and 2 minus 3, that is this, for this 2 minus 3 is also equal to minus 1, so this will give us minus 1, right? Similarly, if we subtract all of these, let's say if we subtract 0 comma 0, right? Let's say for this diagonal, this is a diagonal, this is a fourth diagonal, we can say, if we count it from here, right? So this is the fourth diagonal, and for this diagonal, for this 3, 0 minus 0 is equal to 0, 1 minus 1 is equal to 0, and 2 minus 2 is equal to 0, right? So this will give us 0. Similarly, if we will see, so this diagonal will give us 1 and this diagonal will give us 2, right? Because for this one we have 2 comma 0, right? And 2 minus 0 is equal to 2. So if we just see for the each diagonal, we are getting a unique value of I minus j, right? We are getting a unique value of I minus j, right? So we just need to sort all those values, right? We just need to sort all those values which are present in I minus jth diagonal, right? So let's say we have a diagonal with I minus j value is equal to minus 3. So for this diagonal, let's say we call this diagonal as minus 3. So for this diagonal minus 3, we will just sort all the values. Similarly, for diagonal minus 1, right? Let's say we make a map, and in that map, we just store this I minus 1 as a key, and we just, we will just sort this, right? We will just sort this on the basis of this value, right? I hope this is somewhat clear to you. What we are basically doing is we will be just storing a key with I minus j, right? We will be storing I minus j as a key, and all other values, right, all other values in data structures, we can say. So in that data structure we will be storing all these values. Let's say we store 3 comma 1 comma 2, right? this we store. Now what we basically need to do is we need to sort this somehow, right? We need to sort this somehow, and the sorting pattern must be ascending, right? Sorting pattern must be ascending. So we can use a min heap here, right? We can use a min heap here. So what does this min heap do? This min heap will give us topmost element as the lowest element among all the element, right? Let's say we store these elements. So first we will get 1 as the topmost element, then we pop it out, then we get 2, and then we get 3, right? So this is the algorithm we will be using in this question, right? So let me just repeat three statements. The first statement is, first we will create a map, right? First we will create a map. In that map we will be storing I minus j as a key, right? I minus j as a key. And the second one would be min heap. Let me write priority queue, right? So this will be our first step, right? Then the second step would be, in the second step we will just traverse through the whole matrix, right? We will just traverse through the whole matrix and store the values in this map, right? We will just traverse through all the values and store the values in this map, right? Let me just write it here, store the values in the map. And the third step would be, right, the third step would be to update the value, right? To update the value in the matrix. So these are the three steps we will be doing in this question, and this is quite an easy question, I would say. So let's quickly code it up. If you still have any doubt in this approach, feel free to comment it down. I will try to explain it again. Let's quickly move to the coding part. Alright, so let's take two integers. Int r is equal to mat dot size. This will be storing the number of rows. And let's take another integers. Int c is equal to mat 0 dot size. This will be storing the number of columns, right? Now let's see the three steps we discussed. The first step is we need to create a map, right? So the first step is we need to create a map. So let's create a map, an ordered map of first one. The key value is I minus j, right? This is I minus j. So I minus j is integer, right? This is integer. So let's take an integer, and second one is priority queue, and that too is min heap, right? So let's quickly write integers comma min heap. So for this min heap we use priority queue of integers, and we need to make it min heap, so we need to write few more statements. So this would be vector of int, and another one would be greater int alright, and let's name it m because it's a map, so let's name it m, right? Now we have just completed the first step. Now the second step is we need to store the values in this map, right? So let's do this. Let's run the for loop to iterate through whole matrix. So int I is equal to 0, I should be less than r, and I plus plus. Similarly, let's run another for loop for int j equal to 0, j should be less than c, and j plus plus. Right, now let's store the values into the map. So what is the key? Key is I minus j, we already discussed, and that should be having the value. So push mat I and j. Right, so we have just completed the second step, that is storing the values. Right, now let's quickly write the third step. So the third step is we need to update the elements in the matrix so that the elements are sorted, right? So let's again run these for loops. So for int I is equal to 0, I should be less than r, and I plus plus. And let's run for int j is equal to 0, j should be less than c, and j plus plus, right? Now let's update the values. So we are just updating I and j with the value which is stored in the map on the key I minus j, and this value should be the minimum one, so this must be present on the top of the element. and let's pop it out so that in the next iteration we get the next smallest value, right? So let's just pop it out from here. So mi minus j dot pop, right? So this will update the matrix with the sorted diagonals, and at the end just return this matrix from here, right? So I hope this should be fine. Let's try to run this on the simple test cases. Yeah, it's running fine. Let's submit this. Yeah, it's running fine. So let's discuss the time and space complexity of our solution. So the time complexity of our solution would be R into C, because we are just traversing through all the rows into column elements, and the space complexity would be also equal to big O of R into C, because we are storing all the elements into our map, right? So I hope you understood the solution and the approach. If you still have any doubt in this question, feel free to comment it down. Please like this video and subscribe to our channel. I will see you in the next video.